Here are your solutions to 4-3 guided practice functions. Problem number 1, they ask us to find f of 4 if f of x equals x minus 6. Well, remember the idea here is to find f of 4 if we place it in the equation for x. So we would have, instead of x minus 6, we end up with 4 minus 6, and that we can easily determine is negative 2. So our first answer is negative 2. Our second problem asks us to choose 4 values for x to make a function table. So we're going to use negative 3, negative 1, 2, and 4. And in order to check that, we're going to do 8 minus our input of negative 3, 8 minus our input of negative 1, 8 minus our input of 2, and then 8 minus our input of 4. Of course, this is like adding, instead of subtracting, a negative 8 plus 3 would give us 11. 8, again, we can turn this into addition, is 9. 8 minus 2 is 6. And 8 minus 4 is 4. So now they also asked us to state the domain and the range. So I'm going to do that over here. The domain would be our input or x values in ascending order would be negative 3, negative 1, 2, and 4. And our range, our output values, would be 4, 6, 9, and 11. You do not necessarily, in fact, if you look in the back of the book, every once in a while they'll do this differently. You don't have to put them in ascending or descending order, but we are always going to put them in ascending order so that when we check in class, everybody's doing it the same way. Problem number 3, a hot air balloon can hold 9,000 cubic feet of air. It is being inflated at a rate of 6,000 cubic feet per minute. The total cubic feet of air, A of t, is a function of the time in minutes. So in other words, if you think about it, we can make an equation here. It said the total cubic feet, A of t, well, from the sound of it, hopefully you recognize that as an output. So our output, A of t, is a function of the time in minutes, and we're filling at 6,000 feet per minute. That's easy to see as a unit rate or a slope, and we multiply that by our input of t. So the first thing we need to do is identify the independent and dependent variables. Air, A of t, is the dependent variable, and the time t is the independent variable. Time t is the independent variable. Think about it. Time does not depend really on anything if you think about it, but in this particular case, the air does not depend on time. The time is independent. The number of minutes that we're pumping air determines how much air ends up in the balloon, so that would make that the independent variable. Letter B, they ask what values make sense. Well, in this particular situation, any positive number for the domain. We can't have negative minutes, but we can have any positive number. Now when it comes to the range, we'll write that over here. When it comes to the range, let's look back at it, at the original statement. A hot air balloon can hold 90,000 cubic feet. So for the range, any number between 0 and 90,000 would make sense. In other words, we could have 80,333.5 cubic feet of air in that balloon at any given time. So fractions are perfectly okay, but we can't have negative numbers, and we can't have anything over 90,000 because that's all it holds is 90,000 cubic feet of air. And then the last thing they want us to do is write a function to represent the total amount of air and then determine the total amount of air in 6 minutes. You remember that one of the first things I did was think of A of t as equaling 6,000 times t. We did that right in the very beginning, and now in this case we're asking for 6 minutes. So we have a t value of 6 minutes. So A of 6 is going to equal 6,000 times 6. We can do this in our head. 6 times 6 is 36. And put the zeros back on. There are 3 zeros, 36,000 cubic feet. So that would be feet cubed. Problem number 4, building on the essential question, how does the domain affect the range in a function? Well, the domain affects the range in that just about any value is possible for the domain, and the range is dependent on those particular values that you choose for your input. The range is the output, and therefore it is dependent on the domain. Please do independent practice.